This is Mr. Pat broadcasting from the shed. A combination of transformations. Okay, so similar things where more than one thing happens. So we've got a dilation factor of 2 from the x-axis. So here's our dilation factor of 2 from the x-axis. Remember, if it's from the x-axis, the x stays the same, the y changes, followed by reflection in the x-axis. And the reflection in the x-axis is, remember, the x stays the same, and the y one just becomes negative. So we've done them in steps. We've done dilation from the x-axis first, that's that one. And then we've followed by reflection in the x-axis. Here's another one, a dilation factor of 2 from the x-axis. So dilation factor of 2 from the x-axis, that's what that one does, followed by a translation of 2 units in the positive direction of the x-axis, 2 units in the positive direction of the x-axis, and 3 units in the negative direction of the y-axis. So there's negative in the y-axis. So we've got the 2y there, and that stays, so that one becomes 2y minus 3. Let's look at an example. Find the equation of the image of y equals root x. Now I've drawn y equals root x here just to help us with our visual. Under, this is just the language they use, so find the equation of the image under a dilation factor of 2. So that's what it is, yeah? Let's do it in the right order. Dilation factor of 2 from the x-axis, dilation factor of 2 from the x-axis, followed by a translation of 2 units in the positive direction of the x-axis and 3 units in the negative direction of the y-axis. Okay, so we've set up our situation. We then have to do our mapping, yeah? So that's our original one. That's going to be our image. So x dash, x plus 2. Y dash, 2y minus 3. We then have to rearrange it. So we get x dash minus 2. So if we add that 3 and then divide by 2, it's y dash plus 3 all over 2. Now we substitute back into our equation. So our original equation is y equals root x. So instead of writing y, I write that, y dash plus 3. Instead of writing x, I write x minus 2. X minus 2. So then I do a bit of rearranging. I'm going to have to times it by 2 and then take away 3. Times it by 2 there, take away 3 there. There's the equation. So if we now put that one into our Desmos, so if we now draw this graph, we can see there's the new graph. So we can see it's been moved 1, 2 spaces that way, 1, 2, 3 that way, because my 0, 0 is now the point 2 minus 3. Dilation factor is more difficult to see, but it's a dilation factor of 2 from the x-axis. From the x-axis, so it's a dilation factor of 2 from the x-axis. More difficult to see. There's some notes for us, and there's determining transformations. So this just means working backwards. Find a sequence of translations which takes the graph that to the graph of that. Okay, so we just got to work out what happened to get the graph from one to the other. So by inspection basically means, oh, this is too easy, I can just do it. I can just look at that and I can see what the answer is. So by inspection, we can see it's a factor 2 from the x-axis, followed by a translation of 2 units in the positive direction of the x-axis. Remember, we have to change the sign when we're doing our left and right ones, and 3 units in the positive direction of the y-axis. So some of you will just be able to see that. But let's use a method, because there are going to be some that are too tricky for us to use just by knowing. So y equals x squared is the equation, and that maps to y dash equals 2 x dash minus 2 all squared plus 3. So this is just this, but instead of writing x and y, we're writing x dash and y dash, because that's the image. So we've got this equation. So we're now just going to rearrange it. So it's kind of in the form y equals x squared. So now we know that y is y dash minus 3 over 2. X is x dash minus 2. So now we're just going to do our rearrange. So again, before we would rearrange the other way, this time we're rearranging back the other way. So we get x dash is that, y dash is 2 is that. So now we can tell that it's a dilation factor of 2 from the x-axis. Remember, 2y would be 2 from the x-axis. Translation of 2 units in the positive direction of the x, 2 units in the positive direction of x, 3 units in the positive direction of y, 3 units in the positive direction of the y. Okay. Let's look at the second one, which is a little bit more tricky, and we can't actually do that one by inspection. We can't just know that one. This one's a bit too tricky to do that. So doing the same thing again. So the equation, y equals root x. Our image is y dash equals 5. It's root 5x dash minus 2. So we can see that our y is just y dash. We don't have to do any rearranging here because it's already in the form y equals root x, and our x is 5x minus 2. So then we do our rearrange. So obviously that one's nice and easy because that one just stays the same. This one here, we're going to have to add 2 and divide by 5. So we're okay to leave it like this way, but if we split them up into the two separate ones, when we actually write out what the transformation is, you'll see that it's easier to sort of split them up. So it's a dilation factor of 1/5 from the y-axis. Remember, it's the x thing that has changed. The x is different, so it means that it's in the y-axis where the transformation has happened. Followed by a translation of 2/5 units in the positive direction of the x-axis, so 2/5, and there's no change there at all with the y. So we just have to deal with that one. So that's a 1/5 from the y, 2/5 in the positive direction of the x-axis. You can see that was too tricky to do just by inspection, wasn't it? So there's some more notes for you, and there's some work. 3 questions, 2 questions, too easy for you. Okay, Mr. Patch from the shed, over and out.